All right, so we're going to begin looking at some patterns and trying to connect the patterns to a table of values and then connect that into a formula or an equation. So at different parts in this video, if you want to pause and figure out the answers on your own, please do so. So maybe you could answer the first few questions, pause the video, and then resume to see if you're right. So the first question, how many squares are in the first picture? So all you need to do is count the number of squares that you see and fill in. So for example, I see 7 squares. In the next one, 2, 4, 6, 8, 10, 12, I see 13. So the next one, what I notice is each row has 6. So I've got 3 rows of 6 plus that 1. So the next one will be 19. And then the fourth one, I have 4 rows of 6 plus that 1. So 4 rows of 6 is 24 plus 1 is 25. So I can now answer those first few questions just by counting the number of squares that I see. So now the question asks, if you had to predict how many squares do you think would be in the next picture? So what might help you with that is to visualize what the next picture would look like. So if you notice, the first picture has 1 row of 6 plus 1. The second picture has 2 rows of 6 plus 1. Then there's 3 rows of 6 plus 1, 4 rows of 6 plus 1. So if you were to predict, the next one would probably have 5 rows of 6 plus that 1. And the next one would probably have 31 squares. So now it's asking a little bit harder of a question. What do you think the 10th picture would be? And it could have asked, what would the 50th be? What would the 998th be? Hopefully you're realizing that it is not efficient to just draw out 10 pictures. What's more efficient is to kind of skip that and go to the next question, which asks about thinking about a formula. Okay, so this is a point where you might want to pause the video to try out a formula and see if you're right. So a couple ways to approach finding a formula. So first thing that you want to do when you're making a formula is you're looking for a connection between the picture number and the number of squares that you see. You do notice, okay, if we look at this, hopefully you do see that every time we add a picture, my pen is not there, we're soon to be adding 6 squares. Right? So every new picture has 6 more squares, 6 more squares, 6 more squares. So obviously it's not efficient to just keep going. However, in the 10th picture, so here we have 6, right, plus 1. Here we have 6 plus 6 plus 1. Here we have 6 plus 6 plus 6 plus 1. And then we have 6 plus 6 plus 6 plus 6 plus 1. So if we were trying to generalize this into a formula, what's a faster way of writing 6 plus 6, or 6 plus 6 plus 6, or 6 plus 6 plus 6 plus 6, right? It's to multiply. You'll notice that this is really 6 times 2. And where's the 2 come from? The picture number. This one is 6 times 3. And where's that 3 come from? Again, the picture number. This one, we have 6 times 4. Where does that come from? The picture number. So what would the 10th one look like? Well, it's probably going to be 6 times 10. And then notice, what do all of these have in common? They all have this plus 1. Okay? So the 10th one would then be 60 plus 1, or 61. We can notice that in our pattern. There is our 6, there is our 1. There are our 2 6s, there is our 1. There is 3 6s, there is our 1. So what would a formula be then? What's a way of using algebra to represent this? So the x number of picture, it could be 100, it could be 1,000, it could be 997. We could say 6 times x, x being the picture number, plus 1. And that would be an equation that we could use to represent our pattern. And if we were then asked to, for example, if we use that equation, I'm going to call it y equals 6x plus 1, where y is the number of squares. Whoops, I can't write. And x is the picture number. If you were asked, for example, 997, all you would need to then do is substitute 997 in, and then get your calculator. And you get 5,982. Whoops. And add 1, and you'll get 5,900. So the pattern or the formula is really, really useful because it helps us to make predictions.